This is a production of Cornell University.
So yeah, I'm Bryan Brown. I'm the Integrated Weed Management Specialist with New York State IPM, which is right across the street from Barton. I'm here now actually in the office looking at Barton across the lawn. And I'm going to be talking about 3 different projects that I've been working on that have a mix of research and extension. And I'll start out actually by talking about a project that kind of dovetailed in with my graduate research. I had found some pretty encouraging results in trying to improve in-row cultivation when I was in grad school. And so before I actually started with IPM, I had kind of conveyed those results to the folks here, and actually they were in the process of submitting a large NIFA grant and included some funding for a cultivator, which is great to do this, continue this work that I was working on in grad school. So that was really exciting. And the issue is that, as you can see here, the cultivation can be really effective at controlling weeds between crop rows, but it oftentimes misses these weeds that are right in the row, as you can see in the bottom picture. And there are some tools that are designed to try to disturb this in-row zone to kill those weeds. And these are some pictures of the tools that we ended up purchasing with that grant, thanks to Abby Seaman. And so I was able to continue this research that I had done at University of Maine, which looked at stacking, as I call it, not just using one of these tools, but stacking on 2 or 3 of them at a time so that they're all targeting that in-row zone. And I had tested all different orders and combinations of these tools as I could back at UMaine, and found some in particular that worked well, especially some in this general configuration with sweeps starting, or an aggressive undercutting tool followed by finger weeders, and then some kind of burial tool, either the row harrow or the disc killer, which throw soil on the in-row zone to bury weeds. And so when I got to Cornell, we luckily bought this great GPS guided tractor that further enhanced the effectiveness of these tools, keeping them right centered on the crop row. And this is in snap beans. And let me see if I can, there we go. So the results were really encouraging for me. This was even better than I had gotten at UMaine. You can see the mortality of the weeds, the in-row weeds, in the blue bars there, and then the mortality of the crop, the beans, which we don't want, in the red bars. And you can see that generally, as you go down the line here, moving from 1 tool to 2 and 2 to 3, that the effectiveness generally increases, the percentage of the weeds that are killed. And some of these combinations actually were still fairly gentle on the beans, which I was glad to see. And this is a super slow motion video shot with a GoPro, looking at my favorite combination of those, the sweeps followed by the fingers, followed by the discs. And you can kind of see the action of each tool and how it works the soil. The sweeps are doing the undercutting, the fingers are kind of pulling and uprooting weeds, and then the discs at the end are burying weeds, throwing soil on the in-row zone. And so that's the combination that I found at UMaine to be most effective, and the same held true here at Cornell. And I think that particular order seems to be most effective as well. You've got the most aggressive tools up front, and then you're finishing with burial. So this was really exciting, but this was really kind of an ideal situation. The crop was really well established. The weeds were really small, less than 1 inch tall. So the next step was what we wanted to put this tool and some of the other tools kind of through more of a challenge. And so we looked at beets, which are slow to emerge, and a lot of times the weeds are right about the same level as the beets early on. And so this is a very challenging situation for any kind of tool to be selective and control the weeds without controlling the beets, even though they're anchored in the same way because they're the same height. And we were also interested in the stage of the crop. How early can you use these tools? It's just something that growers were interested in. And as you can see by the red bars, 2-leaf stage beets was way too early. So I would at least wait until you had 4-leaf stage beets. But again, similar results as the snap beans. This combo on the far right, the sweeps, fingers, and disc tillers, performed really well again, and controlling around 80% of those in-row weeds while doing very little damage to the crop. So that was another great result, and I'll hopefully be writing that up for a peer-reviewed article soon. There have been some nice spin-offs of this project. More and more companies now are adding stacked tool setups to their inventory. This one on the left is just a small cultivating tractor from Tillmore, a walk-behind that incorporates a stacked setup. And then on the right, this is a cultivator from probably the 50s or 60s, which the grower has stacked on tools on the back of it. So growers can use these results without necessarily buying a whole new implement. Okay, so that was the first story. The next story I'm going to tell is about trying to control field and hedge bindweed in grapes. And both of these weeds are really competitive in their own right, but they also tend to thrive in grapes because growers tend to spray for weeds either in the spring before these weeds really get going, or they'll spray in the fall after maybe a frost or so, after the weeds are kind of dying down anyways. So what Hans Walter Peterson and I, as well as Don Caldwell in the picture here, wanted to look at was, can we look at some treatments to try to control these weeds midsummer when they're most susceptible to being controlled. So for hedge bindweed, actually at the Teaching Vineyard by Anthony Road Winery, we tested a few different treatments. Hoeing, which was done by hand in a similar way as a tractor might. So the results are somewhat applicable to tractor hoeing. And that was done 3 times. So June, July, and August. Then rimsulfuron, which is an ALS inhibitor, an herbicide, in June and July, not August because of label restrictions. And then glyphosate in June, July, and August. And we were actually surprised that all 3 of those performed very well in controlling the hedge bindweed. And this is a measure of the hedge bindweed biomass at the end of the season in September. The other benefit to the rimsulfuron was that we didn't see any visible injury to the crop. So unlike glyphosate pictured here, where you have this puckering and injury to the crop that could translate to yield loss or loss of quality. And then we came back the next year to those same plots before any activities had begun. So nothing had been done that spring, and looked at just the carryover effects from the previous year's treatments. And you can see in the top graph that the hoeing did have a carryover effect compared to the untreated control. That the hedge bindweed was slower to recover or regrow. But really, the rimsulfuron and the glyphosate were the most effective at keeping that hedge bindweed suppressed into the next year. And that's because both of those products translocate. They go down into the root system and damage the roots and try to target that energy reserve that these perennial weeds have. Whereas hoeing just removes the top growth, and so it can use that energy reserve to regrow. Then if you look at the bottom graph here, this other weed ground cover, so this is other grasses, other broadleaf weeds. Hoeing didn't have any effect on those, but look at the rimsulfuron, it had a very strong effect, and actually stronger than the glyphosate. So that was interesting. And I think what's going on is that the rimsulfuron is a residual product. So it's a soil applied herbicide. It lasts in the soil for a lot longer, certainly than glyphosate. And I think that there's still some activity from that product in the next year. Okay, so we also looked at field bindweed, which is kind of the rougher, tougher sibling of hedge bindweed, and this is a lot more difficult to control. We did add a couple more treatments in this trial. We added the diclobinil, which is Casseron, which is sprayed in the spring, and you notice that when we came back to do the field bindweed biomass, that was in September, the effect had basically worn off, even though it did do a pretty good job early in the season. Hoeing did about as well as would have expected, but rimsulfuron did not affect the field bindweed, unlike the hedge bindweed. So there's some clear differences there between those two species. Glyphosate did a very good job controlling the field bindweed. And then we had a integrated treatment, hoeing in June, glyphosate in July, and then rimsulfuron in August. Of course, we didn't know when we started that the rimsulfuron wasn't going to be effective at all on the bindweed, but nevertheless, it performed statistically as well as the glyphosate treatment. And it actually performed better than the glyphosate when you look at the other weed biomass, so the other grasses and then broadleaf weeds. So again, integrated treatment that is not relying on the glyphosate as much, less apt to cause resistance to build up, and just a more diversified treatment program. Okay, so the final story I'm going to tell is about some work I've done, and I've been leading a project which we've been trying to control herbicide-resistant water hemp. And this video shows water hemp that has actually survived several different herbicide applications, and I am frantically trying to weed whack it before it sets seed, so that the grower is not dealing with this for the foreseeable future and having to pay 4 or 5 times as much money for his weed control program. So one thing early on that growers were interested in was learning which herbicides are these these water hemp plants resistant to and which are still effective. And so some Cornell Cooperative Extension educators, Mike Stanyard, Jeff Miller, Josh Putman, Jody Putman, collected seed from various water hemp populations around the state. And then in Tony DiTomaso's greenhouse, with the help of Kathy Howard and Scott Morris, we actually sprayed these different populations with different herbicides at a range of rates or of doses, from very low doses to very high doses. And this is how you go about testing for resistance. If you can show that that your population of weeds that you think is resistant has a significantly different curve or dose response curve to a susceptible population, which in this case we got from seeds from Canada, then you can say that, yeah, that weed is resistant to that product. And we got some graphs, we got some data that certainly supports resistance. We didn't quite find statistical significance. We didn't have enough replication. We didn't have enough seeds. But Lynn Sosnowski has taken the lead on this project, and I'm really excited to see what she finds this year. I know she's brought a lot of Palmer and water hemp seeds from California to compare. But nevertheless, our next step was to actually test out some of these herbicide and weed control programs out in the field and in these areas that have water hemp. And at these trials, we did a number of field days, and these are some photos from the field days with the co-PIs, Mike Hunter, Jeff Miller, Venancio Fernandez with Bayer, and Mike Stanyard. And we had plenty of water hemp at these fields. It started out like, maybe isn't there not that much, but by the time July rolled around, the emergence really picked up, and this is just extreme weed pressure. You can barely see the rows of soybeans there. And that's what can happen when you've got a weed that can produce nearly 1 million seeds per plant if it's not competing with anything nearby. And then in August, it's kind of outcompeted the crop and taken over. And these are pictures from our untreated control. So in soybeans, our first steps were to just look at individual pre-emergence products. And instead of listing the products' names, I've just listed the group numbers of the products, the mode of action number, site of action number. And as we expected, based on the greenhouse work, group 2, which is actually what the rim sulfuron was in the previous Bindweed trials, as well as group 5, which is atrazine or metribuzin in this case, did not perform very well at all. Whereas we did have some that performed better from group 15 and group 14. So those were just individual products looking to see how much of the heavy lifting they were doing. But we also included some more realistic treatments with a mix of products that a grower might actually implement. And there's a few programs here that are just pre-emergence. There's 2, and then there's 2 that are just post. And then there's 4 that are pre and post, what we call a 2-pass program. And generally, you can see in these contrasts that the 2-pass programs were more effective, as you would expect, but also more expensive. And then in corn, we did a very similar setup. And again, the group 2 herbicide did not perform well. In this case, the group 5 performed better. It was atrazine rather than metribuzin. And group 27 performed the best. So in the rest of the treatments, those with group 27 continued to perform well. And overall, the the pre-only treatments and the pre and post, the 2-pass treatments, perform the best. And I was actually most excited about this last treatment, from an integrated perspective. This was a reduced rate of the group 27 herbicide, followed by row cultivation to control any escapes or weeds that came in after that group 27, and then interseeding of a cover crop. And that controlled 100% of the water hemp. And interseeding, for those of you who aren't familiar, this is seeding a cover crop mid-season in your corn, typically, so that after that corn dries down and you harvest the corn, the cover crop can take off. And it's a great way to overlap crops and not have a gap between having crops in the ground. And it's a great practice, and growers are increasingly becoming interested in it, and it's kind of expanding in New York, especially Western New York. So we wanted to make sure that it was compatible with some of these residual herbicides, that the herbicides didn't kill the cover crop. So we tested for injury, basically. We tested a number of different pre-emergence herbicides and looked for ryegrass injury at the end of the season. And there definitely were some that injured the ryegrass, but there were others that were good options to control water hemp potentially, while also doing this great practice of interseeding. So at each of the field days and some of the winter meetings, we handed out evaluations to see how interested the growers were in what we're talking about and how likely they were to actually adopt the treatments that we're showing them. And of course, I was nervous that everyone was just gonna say none, and that would have been very sad. But that wasn't the case. Growers were interested in most interested in the 2-pass herbicide program, as well as using a mix of different herbicide modes of action, and as well as some of the alternatives to herbicides, especially the cover cropping. And talking with other educators, I think that cover cropping is definitely of interest to growers and something they'd like to pursue if they can. They're aware of the great soil health benefits and other benefits. And so I'll just briefly talk about a quick project that I was involved with related to cover cropping using Roller-Crimped Rye. And this is something that Sarah Pethybridge and Matt Ryan and Julie Kickert were leading, and they very generously let me tag along. And they planted soybeans into the rolled rye residue, and Sarah found that it suppressed white mold really effectively. And I participated in the weed surveys and biomass collection, and found that, as you might expect, it suppressed the weeds as well. And so I'm really interested in looking at this type of cover crop biomass to suppress the water hemp with this herbicide resistant weed. Is it has these seeds that are very small that don't have enough energy to really push through a lot of cover crop residue. And so I think it'll be even more effective than this data on the water hemp. And this summer, I just implemented and got started on a very small initial trial looking at, well, how much residue do you need to control this water hemp or to suppress it using cover crop residue. So just to sum things up, overall, I've just found that integrating herbicides and other tactics is a great way to maximize your effectiveness in controlling weeds. But a lot of times it is a little bit more expensive or just more complex and takes a little bit more to think about. So it really helps when there's multiple benefits, like with that cover cropping example. the weed suppression, but also the white mold suppression and the benefits to soil health. And there's other examples of that with tillage and other things. So those are some those are the kinds of practices that I really like to promote from an IPM perspective. So big thank you to the co-PIs and collaborators that have been involved with this research I presented, and as well as to the funders that made it possible. And for more info, do check out the New York State IPM webpage. Any questions?
Thank you very much, Brian. We have actually a few of them. The first question from Chase. Hey, Brian, is there any barrier to entry for growers to adopt your multi-till strategy? Do they need a GPS tractor or other things?
So you're talking about the cultivation, I think. So yeah, I will say it worked significantly better with the GPS guidance system that we have at FRU up here than back at UMaine without it. But I will say that there are simpler, less expensive ways to guide the tools down the row. The cultivator that we have actually has a rear steering system, so that even if the tractor operator makes a mistake in steering, someone on the back can correct for that and keep the tools directly centered. And there's also a tool I believe I haven't worked with that is very simple, kind of follows the deeper trench behind the tractor tires and just kind of stays in that trench and keeps the tools centered on the rows.
Gotcha. All right, two more questions real quick. Did you observe any weeds that weren't impacted by the multi-till strategy, or was this strategy broadly effective?
That's a good question. I've primarily looked at the stacked tools in annual vegetable systems, and these are primarily summer annual weeds, lamb's quarters, pigweeds, and some summer annual grasses. And it's been, I haven't noticed any weeds that in particular that have been able to survive it. I will say likely perennial weeds would be better at surviving than annuals.
This has been a production of Cornell University, on the web at cornell.edu.